Hello friends, welcome back to our channel. It's GovCAD and it's Godfrey and I'm from GovCAD Engineering Solutions. And we are here to continue with our project which began and we did the modeling, we did the loading, we did the load decomposition, and now it's the time to do the analysis of our structure. As you can see, we have the 3D model here and we have the plan model here. So in the analysis, we shall come here to analysis, look for the building analysis, which is this one. It will bring us this tab here and we have to change a few things here. As you can see, we have to first go to the project parameters, look for the codes. We use the Eurocode 2, Eurocode 3. As you can see, concrete structures we use Eurocode 2. And then the foundations we selected that the unit weight, the allowable stress of the soil to be 200 kilonewtons. This can be got from the geotechnical designs, geotechnical uh, uh, values which we got when we did the geotechnical investigation. Yeah. Then the lateral loading, we have these national loads and nothing much to change here. We have the story weight where they give us the weight of the GK and the 2K, which of them are multiplied by their factors of safety. As you can see, then we have the lateral drift. We don't need lateral movement. That's why our columns are braced and the walls are braced also. Then the title, this one can be in the report builder. We can put here the project title, maybe a proposed uh, residential house, residential house. Made by, you can put GovCAD. Checked by, you can put an engineer here who checked the registered engineer who is going to check your work. Then the project number, it can be maybe project number 1. Then here we put the date, maybe which is 12th, 21st of March 2025. Yeah, checked by, you can put here a registered engineer. Then this one will show in the report builder. When I press OK, it will be in the report builder. Then the next step to do here is to edit the materials. As you can see in the concrete columns, they are specifying for us that the concrete class should be 35 and 45. But if you want to change, you can change from here. Click in it, come to, let's say we need a concrete class of 20. Press here and then apply to all members in the story. Then press OK. As you can see, all this from here up to here will be changed into class 20 and class 20. And the grade of the steel, you can also click here. You need maybe grade 500, you have 460. You can change from here and then apply to all members in the story. Press OK. Then in the river diameters, as you can see, we have very many selected here. And as I told you, we have to maybe select all and select and then unselect. And then we have to check for the columns which bars we need. We can need a T16, we can need a T20, or maybe a H12, any of the values you want. Then press OK. We can go on the concrete walls. The concrete walls we can specify and maybe go to H12, H10, maybe remove H8 and press OK. For the longitudinal bars, nothing to change here, but we can maybe limit it to H16 and H10 and H12. Press OK. The horizontal web bar, let's leave it at that. The concrete beams, limit it to H20 and H16 or H12. Remove H10 and H8. Press OK. The slabs, write the first numbers. Let's take it to H10 and H12. Yeah. Press OK. Then the ribbed slab, the rib, the rib beams, the ones which are found inside the max span, we can limit it to also H10 and H12. Yeah. And then press OK. Uh, the links the shear connectors, we can limit it to H8. Press OK. And then for we have not done the steel part of it, so we have to leave this one default because we don't have any steel structure. After we have done the steel structure, we shall always also check for this. This one was the default materials. We can go to also the foundation floor. Then we look for this. The concrete class can also choose 20 to 25. We apply to all. Press OK. The soil here we need to check which soil do we have in an area. Is it sand? Is it clay? Is it silt or it's a rock? We can leave it at sand. Press OK. And then we have the grade of steel. We use 500. Press OK. The links also use 500. Press OK. And then the rubber diameters in the foundation, we can use H16 and maybe H12. Press OK. Then the links, as the links here connectors, they need not to be of a higher diameter. Let's leave at H8. Press OK. And then press OK. As you can see, we have finished editing our materials. And then the next part to do is to run the analysis. In running the analysis, we have building model check. We have first check the model for overlapping slabs, overlapping columns, and we have start and check if we have any overlapping items. As you can see, uh, building model check completed. Number of errors we have 0. So we have no overlapping in the beams and the slabs, the columns. Now, so we can close this. And then the analytical model, let me leave this one so that you can see what the analytical model is. And then run the building analysis. But for this time, you can do the design from here. But in the next video, it's when we shall design the beams. Yeah. So for now, I can do the building analysis and check the uh, uh, check how the steel bars will be arranged I do the before I do the design of the beam. Yeah. So the building analysis is taking place. As you can see, it is taking the beams, the columns, the slabs, the loads, everything. So they are telling us the warning difference between the decomposed loads and the slab loading. Yeah. So this one shows this error happened because uh, all the loads from the top of the story to the bottom have not been decomposed by an error of 6.5 here. You can check the building model and see where you could have made or carried out a very difference, or maybe you have like different planes, maybe different things, but this error is not within the vertical component. Yeah. So we can press OK and then close this. And then before we close that, actually it is displaying the analytical model. But before I move out of this, I have to generate the actual load comparison report. Yeah, it shows me that the columns had this the column on the third story had a weight of 143. This one had 134. The wall, we didn't have walls, shear walls. We had beams. Beams also were carrying some wall loads, so that's why we have a lot of here. We have the slab load, as you can see. We have the ribbed slab load, and the total load gives us the 6,902 kilonewtons. The live load, we have the beams having some wall loads. Uh, we have the slab with some load, the ribbed slab, uh, and this giving us the total. Then the decomposed loads, here we had 6,900, but here we have 6,700. And also here 995, and this one is 89. Yeah. So the 65% is showing us that difference. But this difference has no effect on the load. As you can see, if we want this report to be in the report builder, we open it and we don't close it. We close it. For it, it will show in the report builder. Actually, it is showing, it's launching it. And then we can close this. Then after that, I can maybe pull and I show you my analytical model, which is this. This is my analytical model. We can see the displacement. As you can see, the displacement caused on the beams. Actually, we can also see the diagrams. Uh, uh, we can see the diagrams. We can look for a worst scenario, maybe this one, this line. It can be all stories removed, and then we can remove maybe can remain with remove this, remove that, remove that, remove that, remove this, remove this, remove this. Actually, I want to maybe look at this scenario where we have beam this way. We can see the bending moment diagram. Here we have 19, here we have 18, we have 18, we have 18. The bending moment diagram, as you can see here, we need to maybe reduce the span or increase the 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 steel in this. But this one is all going to show us in the analysis. We have run the analysis and we are going to design. Actually, it will show us the steel that the picture needs. We can take a snapshot of this, and then we also put in our our report. Yeah, as you can see, it will be shown here. You can put it in our report. You can save it maybe to desktop, and then after we shall find it there. So this is all about the analytical model. It can show us the shear force diagram. It can show us the actual load. Yeah, as you can see, that's the way the analytical model shows very many components. We can close this and still have our structure. So we have completed the analysis, and the next time we shall do the the design of the beams